Imagine you're in Manhattan in the late 1970s. A brand new skyscraper, the CityCorp Center, just opened. It's supposed to be a marvel of modern engineering, sleek, tall, and iconic. But then, something terrifying happens. Its structural engineer, Lameshrier, discovers a flaw. Not a small flaw, this one could make the entire building collapse in the middle of New York City. And the winds needed to trigger this disaster? Just 110 kilometers per hour. That's not even a hurricane, just a strong storm. Over 200,000 people lived and worked around that building. Hurricane season was approaching, and suddenly, Lameshrier realized he might be the only person in the world who knew the city could die because of his skyscraper. Now let's go back a bit. In the 1960s, CityCorp wanted a new headquarters in Manhattan. They bought an entire city block except for one church, St. Peter's. The pastor said, "We're not leaving. Your building has to work around our church." So the architects and engineers had a huge challenge: build a skyscraper around a church without touching it and make it stable. Lameshrier came up with a bold idea. The building would stand on stilts, but not at the corners. At the center of each side. Imagine a chair with legs in the middle of each side instead of corners. Not very stable, right? That's exactly what made this problem so tricky. To solve it, he invented a chevron bracing system. These diagonal braces would transfer the building's weight and handle strong winds. But it wasn't simple every 8 stories. The weight would be forced into the braces, and the braces would channel forces down to the stilts. It was a delicate balancing act, entirely new in engineering history. And there was another problem: wind. Skyscrapers sway. Normally, engineers just make the building stiffer. But Lameshrier did something smarter. He used a tuned mass damper, a massive block of concrete on the top floor, to absorb the sway. As the building moved, the damper moved in the opposite direction, stabilizing the tower. Ingenious, elegant, and effective. So by 1977, CityCorp Center opened. The press called it an acrobatic act of architecture. Everything seemed fine. Until May 1978, Lameshrier got a casual phone call that would change everything. It turned out the chevron braces, originally designed to be welded, had been bolted, instead saving money, but reducing their strength in extreme winds. He ran the calculations, and then he realized some braces on the 30th floor only had 4 bolts, but under certain wind conditions, they actually needed 14. If a strong storm hit the city, the building could collapse. Suddenly, Lameshrier wasn't just an engineer, he was someone who had the lives of thousands in his hands. He called experts, ran simulations, double-checked every floor, every joint. He calculated that in any given year, there was a 1 in 16 chance that winds strong enough to cause collapse could hit New York. Just 1 year before, a storm had almost tested it. Lameshrier had a choice: stay silent and hope for the best, risking thousands of lives, or act and face lawsuits, professional ruin, and public panic. The ethical choice was obvious but terrifying. He informed CityCorp and started a secret operation called Project Serene. Every night, welders repaired the critical braces over 200 joints without anyone in the building knowing. Emergency evacuation plans were made. Strain gauges were installed to monitor the building's every bend. The repairs had to be done before hurricane season, and the city didn't even know. And then came Hurricane Ella in 1978. Winds reached 200 kilometers per hour, but at the last moment, the storm veered out to sea. CityCorp was safe. Lameshrier finished the repairs 6 weeks later. Today, the building can withstand a 1 in 1,000-year storm. For almost 20 years, the world had no idea how close Manhattan had come to disaster. And when the story finally came out, instead of being vilified, Lameshrier was praised for taking responsibility and saving thousands of lives. This is a story of brilliance, risk, and ethics of a man who realized that engineering isn't just about structures, it's about people,